Welcome back. So in this clip we'll talk about the size of the particle instancer. So let's create some custom attributes. We can go inside the nParticle shape 1 and let's move to the per particle attributes, and we have already utilized the my shape that is basically controlling the randomizations of our instances. Alright, so now let's do one thing. Let's go to the add dynamic attributes. Inside the general we can pick the per particle array and we can have the float. So you can add your custom name that can be any name, let's say my underscore scale, so that it would be easier for you to memorize. And now let's go inside the my scale attributes, and let's say we can use this by typing nParticle shape 1 dot my underscore scale equals to a value of, let's say, a random value, let's say 0.65 comma maybe 0.1, and we'll see that if the value is way too much low, then we can certainly revisit the settings and can tweak down the values. So hit the edit. Now you need to go inside the instancer. As you all know, we can definitely utilize the all data types, and with that we have the scale, and you can pick that thing which is the my underscore scale. Not a problem, they need a refresh, so let's cut down the frame length and let's rewind the timeline. So here we go. So now you can see we are now getting some sensible kind of destruction, because now the scene is not kind of a messy, like all the particles are way too much big and all. Now we are actually getting some more sense, some aesthetical sense, I should say. Alright, so now the important thing is that, guys, let's do one thing. Let's configure the actual particle size, because this is just the instancer, and you know that these instances are simply bind to the spherical particle. So if I go inside the shading, and you can see I can change the particle type to the sphere. So notice that right now all the particles are basically sharing the same radius. Well, don't you think so that technically the particles having the bigger shape should have some bigger radius, and the particles which are having the smaller shapes should have some smaller radius? Well, that can be possible if we take another pp attribute, that is, let's say we have the radius pp. Alright, now inside the radius pp, if I can use this expression, let's say the nParticle shape 1 dot radius pp equals to, let's say we have a value of 0.35. Alright, and we can multiply this thing with respect to the my underscore scale. So we have my underscore, so it simply means that now the radius of the particle is getting multiplied with the value of my underscore scale. So for those instances whose value is 0.1, then definitely it will affect the overall radius of the particles. Let's take a look inside this, and then you get to know. Now if I just replay, you can notice, yes, there's something nice. And now if you just take a look at this, you can notice the particles are having a different radius. Look at this. Or I do one thing, I'll just hide the instancer for the better visualizations, and now you can see absolutely nice and fantastic. So if in case you just want to increase the overall radius of the particles, let's say we are using a value of maybe 0.45 or maybe 0.5, and then you can notice that your particles are simply responding to the expressions, and that is something nice. So for the smaller instances, the particle size is small, whereas for the bigger instancer the particle size is big. Alright, so this can be some effective technique, although it's not very 100%, I should say, accurate, but still it is 90 to 95% accurate thing for you, and this is obviously very useful also. Alright, so now let's get back to the points and let's enable the instancer once again. Now it's time to improve the rotation and the spinning of the particle. So for that we are again required to create some more custom attributes. So we can go inside the general, go for the new tab, and using the per particle again with the float value, let's say we have the rotation. So let's say my underscore, let's say we have a value of spin, hit the option OK. Now you can go inside this, and very simple and straightforward, you can have nParticle shape1 dot my underscore spin equals to, let's say, a random value of 360, and we can simply multiply this with a value of, let's say, rand1 comma -1. Alright, so some of them will have the opposite, or you can simply put a comma and can go with a -360 also, whichever way you want. Hit the option edit. Now we can use the same thing over here. Let's say we have the rotation and we can link this with the my spin. Alright, so now if I play, well, this is a little less noticeable because the default particles were also during the time of their selections, these were obviously they were randomized in their rotations. Not every one of them were facing to a specific direction, so we cannot just simply configure this. But yes, there is another method of making them spin in the per frames. So right now you can see these particles are not basically spinning. So how can I just simply control the spinning of the particles? Again, pretty straightforward. For that, let's say I am building another attribute, that is the speed. So I can utilize the speed as the magnitude of the velocity, so that we can simply multiply the the speed with the spin attribute. So whatsoever is the velocity of the particles, the rotation can take that advantage. So let's say we have the speed over here and hit the OK. Now inside the speed, you can go inside the runtime before dynamics, and let's say we can have nParticle shape1 dot speed that is equivalent to the magnitude of the velocity. Alright, and hit the option create. Now it's a straightforward thing. We have nParticle shape1 dot my underscore spin, that is plus equals to, because every frame we want the incremental value, so plus equals to the speed. Alright, and if in case the speed is less, we can simply multiply the value with the 2.5, maybe 5, whichever way you want, if you just want your particles to have some higher frequencies in terms of the rotations. So now if I play the timeline, just notice very carefully what do we have. If you can see carefully, your particles are now wonderfully spinning, rotating. Alright, so this is something which is very, very nice. Alright, now we'll talk about some important things with respect to the overall behavior, and you can say the stabilization of these particles, because one thing is very, very important, and I think so I'd like to continue this thing in the next clip, where we talk about some issues and some little minor issues. And so let's do one thing. Let's move inside the next clip where we talk about the bounce scale per particle attribute of the particles. Alright, so see you there in the next clip.